Warm up for lesson 4-3 part 1. Pause the screencast to do the problem. And here's the answer. Pause the screencast. And here's the answer. Notice that there were two equations. One, the sum added to 5, and the product made -14. I'm going to solve for y on the first one and then substitute it in here. And now I have a quadratic equation. I move everything to one side. Go ahead and graph it, and you'll find that the quadratic intercepts the x-axis at -2 and 7. Lesson 4-3, solving quadratic equations by factoring. Objective, write quadratic equations in intercept form. Solve quadratic equations by factoring. This is part 1. Let's take a look at the advantage of a factored form versus the standard form. So this is the standard form, and this is the factored form. The factored form reveals the factors, and with the factors, what we can tell about it is when it crosses the x-axis. So let's take a look at this factor, and notice that when we graph it right here, it's crossing at 6. And when we look at the other factored form, notice that there is a tie-in between this factor and the fact that it crosses at 2. These are called x-intercepts. Let's take a look at the FOIL method. The FOIL method is a distributive property to help you multiply binomials. And so right here, a little review of FOIL, multiplying the first terms, the outer, the inner, and the last. Let's write a quadratic equation in standard form where we know the roots, -1/3 and 6. So here's what we know about the parabola. And so what we're going to do is we're going to write the pattern x minus p, x minus q. This is the pattern. And what we're going to do is substitute for p. We're going to substitute this value, and for q, this value. Now we're going to use FOIL to help us multiply it all out. And then to make it look nice, we're going to multiply each side by 3 so we get rid of this fraction. All right, let's go ahead and go through a guided practice. We want to write a quadratic in standard form. And right now we know that the parabola crosses the x-axis at -5 3/4. So what we're going to do is we're going to go to the pattern, x minus, and we're going to write a 3/4 here, and then we're going to write a -5. Now if we clean things up, these two negatives make a positive, and then we're going to use FOIL to help us multiply it all out. And because we have fractions here, I'm going to multiply everything through by 4. Every one of these two terms is going to be multiplied by 4. And then these are like terms, and we're going to get 17. So this is what we call standard form. All right, let's go ahead and let you try. Go ahead and I'll get you started. You're going to start with a pattern, x minus p times x minus q equals 0. And then you're going to substitute your p, and you're going to substitute your q. Go ahead and stop the screencast and see if you can do all the algebra steps. And here's the answer. All right, let's go ahead and start solving equations by factoring. Now to do that, we're going to have to use what we call a zero product property. And this says that anytime two numbers multiply to 0, either a is 0, b is 0, or both of them are 0. So for instance, if we have this factored form equaling 0, then we can say x plus 3 equals 0, or we can say this factor x minus 5 is equal to 0. All right, let's go ahead and start example 2, which is factor using the GCF, greatest common factor. Now notice that they each term has an 8x in each of these terms, so we can factor it out. And now we have a product. Once we have a product, we can set this equal to 0, and we can set the other factor equal to 0. And this is what we call our solutions. We can call them also roots of the equation. Let's take a look at the guided practice. In here, if you're having trouble figuring out the GCF, then what you can do is put everything in factored form, and when you do this, you can see that there's an x in common for both of them and a 5 in common for both of them. So that's what you want to factor out. Now once you get the two factors, you can set them equal to 0, and then we can get our roots, our solutions. And the same thing is happening here. If you break it down into its roots, there's a common root y, a common root 4, and you can factor that out. And go ahead and stop the screencast so that you can look at this in more detail. Okay, your turn. Pause the screencast, and here's the answer. All right, let's go ahead and start solving equations by factoring. And this first one we're going to see as what we call a perfect square trinomial. And in a few minutes you'll see why we call it a perfect square trinomial. Let's go ahead and use the AC method. Remember, the AC method is this is our first term, which is 1, and this is our C term, which is 64. So you're going to multiply these two, and you're going to put the number here. And then you're going to put the middle number here. And what we're looking for is what numbers multiply to get 64 but add up to 16. And that answer is 8. Because 8 times 8 makes 64, and 8 plus 8 is equal to 16. So we know that we can write x squared plus 8x plus 8x plus 64. And then what we can do is we can factor out an x, and we can factor out an 8 on this one. And we can see that the common factors are x plus 8. So then we can write x plus 8. That's our common factor. And then what we have left is x plus 8. And notice that they're exactly the same. And this is why we call it a perfect square, because it's just the factored squared. Now, when you set these both equal to each other, the answer is going to be -8. Now let's take a look at this one. This is called a difference of squares, and the reason it's called difference is if you take the 64 to the other side, this is the word difference, and here's a square in a square. Let's go ahead and use the AC method again. The first term, 1 times 64 is -64. There is no middle term here. We want to look for two numbers that multiply to get -64 but add to 0, and those will be -8 and 8. Those multiply to be -64, and they add up to 0. So we're going to have x squared, and then we're going to have minus 8x plus 8x minus 64. And then we can factor, and then we can take an 8 out. And you notice that the common factor is x minus 8. And then we're going to have x plus 8. Now this is a lot different from the one we had before. Notice the the factors are different. They're different by a sign right here. And that's always going to happen when you have a difference of two squares. And then when you go ahead and use the zero product property, you're going to get two answers. Okay, let's go ahead and continue to practice. I'm noticing that this is a perfect square, and I see that by the fact that the first term is a perfect square, the last term is a perfect square, and if you double this, you'll get the middle term. Okay, so AC method is going to help me with this one. So I'm going to multiply this and this, which is 36, and I know I need to add up to -12. And the only way that that's going to happen is if the two terms here are -6 and -6, because these times together to give you a positive, and they add up to this. So this is going to be 4x squared minus 6x minus 6x plus 9 is equal to 0. We're going to factor, common factor is 2x, and then that'll be 2x minus 3. And then the common factor is, I'm going to say -3. And then when I do that, I'm going to get a 2x minus 3 is equal to 0. Notice that we have a 2x minus 3, that's common, and then 2x minus 3. Now you can see that it's a perfect square because both of them are the same. So you only have to set one of them equal to 0, and the answer is 3/2. Now this particular problem, we have a GCF. How do I know I have a GCF? Because this is 9 times 9 times x minus 9 times x equals 0. So I can remove a 9 and an x, and I'm going to have 9x minus 1 equal to 0. I have two factors set each equal to 0. And one of my answers will be 0, and my other answer will be 1/9. So these are my two answers that make this true. Over here, this is another opportunity for GCF. This is 3 times 2 times a minus 3 times a equals 0. I can see I can remove a 3 and an a, and I'll have 2a minus 1 equals 0. Set each equal to 0, and we'll get a equal to 0, and a is equal to 1/2. Okay, let's do a guided practice, and we're going to use AC method. Remember, the number here is 1. 1 times 30 is 30, and we're going to put a negative 11. I want to find two numbers that multiply together to make 30, but add to negative 11, and that will be negative 6 and negative 5. They will multiply to be 30 and add to that. So now I have an x squared minus 6x minus 5x plus 30 is equal to 0. So what I've done is replace the negative 11 with this. Now I do common factors, factoring by grouping. So this is going to be x times x minus 6, and then I'm going to remove a 5, or negative 5, and this will be x minus 6, because I want to try and get common factor. So then I get x minus 6 is one of my factors, and x minus 5 equal to 0. And then I set each equal to 0, and x is equal to 6, or x is equal to 5. Okay, here another AC method. Unless you have another method that you want to use, this is going to be negative 21, and it has to add up to negative 4. So this looks like that will be, I know that's 7 times 3. I know I have a 7 times 3, but I need a negative 7 here, so that these multiply to be negative 21, and they add up to negative 4. So this is going to be x squared minus 7x plus 3x minus 21 is equal to 0. So this is x minus 7 plus 3 times x minus 7 equal to 0. X plus 3 will be one of my factors, and x minus 7 will be my other factor. So this will be x plus 3 is equal to 0, x minus 7 equal to 0, x is equal to negative 3, or x is equal to 7.